the binomial distribution. In this module, you will learn about the binomial distribution. Consider a bag with a small opening and containing 3 red and 7 black balls in it. Let us say you drew a ball from the bag at random, examined it, and then put it back into the bag. Now, suppose there is a condition. Getting a red ball is a success while getting a black ball is a failure. The probability of drawing a red ball from the bag, that is, probability of success, is 3/10, and probability of drawing a black ball from the same bag, that is, probability of failure, is 7/10. If you repeat trials of drawing a ball from the bag with replacement 3 times, then the probability of success in each trial remains 3/10. Also, the successive withdrawals of ball are independent experiments. Thus, the trials of drawing a ball with replacement are Bernoulli trials. Consider a case of getting 0 successes or 3 failures. 3 failures can occur only in one combination, or you can say that the possible combinations for 0 successes are 3 factorial upon 0 factorial into 3 minus 0 whole factorial, that is 3C0. Now, the probability of getting 0 successes or 3 failures is 3C0 cube. Now, in the case of getting 1 success, there will be 2 failures. 1 success and 2 failures can be obtained in 3 combinations. In other words, you can say that the total combinations for 1 success and 2 failures are 3 factorial upon 1 factorial into 3 minus 1 whole factorial, or 3C1. Thus, the probability of getting 1 success is 3C1 into PQ square. Next, consider a case of getting 2 successes. This indicates that the number of failures is 1. 2 successes and 1 failure can be obtained in 3 combinations, or you can say that the total combinations for 2 successes and 1 failure are 3 factorial upon 2 factorial into 3 minus 2 whole factorial, or 3C2. The probability of getting 2 successes is 3c2 p square q. Now, last case is getting 3 successes. This implies that you get 0 failures. 3 successes can occur only in one way, or you can say that the possible combinations for 3 successes are 3 factorial upon 3 factorial into 3 minus 3 whole factorial, that is 3c3. Finally, the probability of getting 3 successes is 3c3 into p cube. Now, if a random variable x represents the number of successes, then probability distribution for x is as shown here. Now the probabilities of 0, 1, 2 or 3 successes represent the first, second, third and fourth term of the binomial expansion q plus p whole cube. This is why such probability distribution is called a binomial distribution. Since the sum of the probability of failure and probability of success is equal to 1, the sum of the probabilities of 0, 1, 2 and 3 successes is also equal to 1. This discussion helps us to conclude that in an experiment of n Bernoulli trials, the probabilities of 0, 1, 2 and so on till n successes is given by the first, second, third and so on till n plus 1th terms in the expansion of the expression q plus p whole raised to the power n. Since q plus p whole raised to the power n is equal to the summation of ncx into p raised to the power x into q raised to the power n minus x, where x varies from 0 to n, the probability of r successes is given by the expression ncrp raised to the power r into q raised to the power n minus r, where r varies from 0 to n. The probability of r successes is also denoted as PR and is called the probability function of binomial distribution. Any binomial distribution with n Bernoulli trials and probability of success as P in each trial is generally denoted as BNP. In this module you have learnt that probability of getting r successes in a binomial distribution BNP is NCRP raised to the power r into q raised to the power n minus r, where value of r is equal to 0 to n.